dependencies from the last class. So we were going over this example, this table with 4 attributes. I think the ones we did in class last time had 3 attributes. So the question was, I have these on the right. Does A multi-value determine B? And then I have a few more of those. So in order to check this, so to check whether A multi-value determines B, let's look, we only have 2 values for A. It's 1 and 2. So let's look at 1. So we have 1, and we're looking at B. So 1 maps to 10 and to 20. So this is A, this is B. Now, so then we have to check for multi-value dependencies. Remember the example we had about John, employee, the projects he works on and his dependents. So it's the same idea. So we have, if you think of A has the employee and B has the projects, then C and D could be dependents. So we have 100X and we have with 10, we have 100Y. And for 20, we have, so we have to see whether with 20 also you have 100X and 100Y. That's the important thing. So with 20 also we have 100X and 100Y. Okay, so the value 1 satisfies. But when you're trying to prove something, you have to look at every value. So we also have to look at 2 and see if it works. Now 2 is, we have the same thing with 2. We have goes to 10 and 30. And then we have okay, so we only have these 2 values. So, and you can look at it and they both satisfy. So therefore, A does multi-value determine B. Similarly, you can do for CD, does it satisfy? Let me just do one for CD since we are out here. So we have A does, so I'm looking at A, does it multi-value determine CD? So we have for C, for 1, we have 100 and X, and for 1 we have 100 and Y. So and if you look at this for X and Y, we both of them we have values 10 and 20 and 20, and similarly we can look at 2, the same thing for 2. So okay, so we have A does multi-value determine CD, and similarly you can look at all the others. Does A multi-value determine C? Yes. Does A multi-value determine D? And you can check this out. It will multi-value determine D. So all of these work, they do multi-value determine. So the next one is, does B multi-value determine A? So for B, we have the values of 10, 20, and 30. Okay, so we have these values. So let's look out here. We have for 10, 20, and 30. So for 30, we can just look out here. Does B multi-value determine A? So we have 30 goes to 2 and 30 goes to 2. So 30 we don't have to look at, because that works, because it only goes to 30 is just mapping to 2. So there's no problem there. And if you look at 20 out here, 20 is just mapping to 1. So there's no problem. 20 is satisfying. So what we really need to look at is 10, because 10 goes to 1 and 10 goes to 2. So we have to check whether that will satisfy. So let's look at. So we're looking at, does B multi-value determine A? So we're going to look at the value 10. And 10 goes to, I'm just going to have to bring the table down because otherwise I have to keep going up and down, which is a bit of a pain. So let me just copy this down. Okay, so I have it there. So it's much easier to see it. So we have 10 goes to 1 and 2. So for 1 goes to 100x, y, 2. Okay, so here you can see very clearly that B does not multi-value determine A, because we have 100x and 100y out here, and we have 200x and 300y here. So it's like saying that John has works on projects 1 and 2, but it's showing different dependence, and that's not possible. So therefore, B does not multi-value determine A. So, so does anyone have any questions on this part? Do you get this? So I'm assuming that you all got this. If you wanted, in order for B to multi-value determine A, you would have to add 200x and 300y out here to the table. You'd have to add this to the table, and you'd have to add 100x and 100y to the table. So that's the only way that B could multi-value determine A. So does everyone understand so far what I've been doing? So the last thing I would like you to check is whether, okay, I would like you to try this out. So check whether, so I did B multi-value determines. Could you check whether B multi-value determines C? I just want you to check that. So it did not multi-value determine A, but does it multi-value determine C? It's pretty easy to look at this one and see it does not, because you can see that for 10, there are 2 different values that are going, but for the others, 200 and 300, there's only one value going. So you can just look there and just see that it does not multi-value determine. So we have, and the values are different anyway. So, I mean, out here, you can see very quickly that it doesn't multi-value determine. Okay, So anyway, so as an exercise, I mean, you should look at some other, you can check with this, you should try some others. Does C multi-value determine A? So you can try each one of those, What about C? Does it multi-value determine A? Does C multi-value determine D? You can just check that out and see if it works. Okay, so if you don't have any questions, let's look at another example. So, so this one, again, I'll take something that's meaningful. So we have, so I'm going to look at employee number, dependent age, project. So I want to show a rule for this one. So I'm going to go back to the same example we started up with, employee, dependent, and project, but I'm adding two other attributes that were not there in the old example. So these are the attributes, and I just want to show a table with these values. So we have, okay, so we have the following attributes, and then we have, oh, so Bob, 2. So Bob works on 2 projects, and he has, no, not Bob, employee 1, 2, 3, 4 works on 2 projects, and he has 1 dependent. And similarly, we have 3, 4, 5, 6, who has 2 dependents, ages 10 and 7, and works on 1 project. Okay, so we have this particular table. So if you look at this table, I mean, if you look at the data, you can see that employee number, multi-value determines dependent and age, because, whenever, and that just makes sense intuitively. I mean, when you have a dependent, like you are going to, whatever dependents you have, you're going to be working on the same projects. And similarly, we have employee number, multi-value determines project number, P name. Okay, so we have employee number, multi-value determines either the dependence data or the project data. So the question that I'm going to ask is, so we know this, so does employee number multi-value determine dependent? So so when we were talking about functional dependencies, if you said A determines B and C, then A determines B and A determines C. So in functional dependencies, this is, it's trivially that is follows. But here the question is that, does employee multi-value determine dependent? So I'm just throwing, what do you think? Or I mean, it's not think so much as when you look at this table, if you look at the table's data, does employee number multi-value determine dependent? So I want someone to answer. It's either yes or no.
I'm going to go with no.
Yeah, it doesn't. I mean, you look at this, I mean, you can, so you can't look at, because, sorry, because
the 10 and the 7 mess it up.
Yeah, you're right. Go ahead.
Oh, I was just saying that the 10 and the 7 mess it up.
That's right. So you can't look at this one because 1, 2, 3, 4 only has 1 dependent, but we can look at Mary and Alice, because so we have 3, 4, 5. So employee 3456 has 2 dependents, Mary and Alice. But if you look at the data out here, for Mary is 10 and 3 GHI, and Alice is, because they're different ages. So you don't, in order for this to multi-value determine, you would have had to have 7, 3. So it does not multi-value determine, just because A multi-value determines B and C, it does not mean that A multi-value determines B or A multi-value determines C. So that's a property, and I'll list on all the properties, later today. I just want to put this down. If A multi-value determines BC, it does not imply, does not, it might happen that it would, but it does not imply that A multi-value determines B and A multi-value determines C. Okay, so I want to put out a few properties. And some of these properties are difficult to prove or disprove, so I'm going to put them down, and I guess it's one of those things that you should keep when you are doing problems with multi-value dependencies. So first, there is this thing about what are trivial multi-value dependencies. Okay, so there are 2 of them. There are 2 trivial multi-value dependencies. So the first one is so remember in one of the earlier classes, I used the bar. So a bar like that would mean many attributes, A1, A2, and so on. And similarly, if I did B bar, it means several attributes together. It's just too much of a pain to write them all down. So I'm saying is if B bar is a subset of A bar, then A bar multi-value determines B bar. Okay, so for example, if I have a table, so an example would be if attributes A, B, multi-value determines A, B, multi-value determines B. So this is called a trivial multi-value dependency. So that's the first trivial multi-value dependency. If B is a subset of A, then A multi-value determines B. So these are trivial. It's very easy to prove them. The second one is if you have a table, if R is equal to the union of attributes A union B, then A bar multi-value determines B bar. A bar. So again, if you take an example out here, so let's say we have a table R with just 3 attributes, A, B, and C. So in this case, you can say that A multi-value determines BC because that's all you have. You only have 3 attributes in this table. So we have AB multi-value determines C, BC multi-value determines A, B multi-value determines AC, and so on. So C multi-value determines AB, and so on. So because that's the whole. So again, this is a trivial multi-value dependency. So there are 2 trivial multi-value dependencies. One is it's a trivial multi-value dependency if either B is a subset of A, the first one, or if R is, the whole table R is A union B, then A multi-value determines B. So these are trivial multi-value dependencies. So I mean, I think, yeah, so don't forget the trivial multi-value dependencies. That's important. So by default. So there are a few rules. So all I can say about these rules, and they're not that easy to prove them. So in general, I mean, it's when you are solving problems dealing with multi-value dependencies, keep these rules to the side because you will need them. So let me just list some of the rules. So I would say, these rules, it's a good idea to memorize them, but, since every quiz and exam is open book, so you don't have to memorize, but you do definitely need to keep it in hand. And let me see which one should I start up with. So those are the trivial. So trivial is also part of the rules anyway. So that's one. So we have, okay, so rule numbers. Trying to see if I should rule it as, okay, let's start rule number 1. If R is equal to, so I'm putting up A, B, and C this time. And we have, and you're given that A multi-value determines B. So if you are given that A multi-value determines B, then that'll imply that A multi-value determines C. So this is written as A So if you only have 3 attributes, A, B, and C, and if A multi-value determines B, then A will multi-value determine C. Okay, so that's rule 1. So then, sorry. Then we have rule number 2. If A functionally determines B, then A will multi-value determine B. Okay, so if it, I mean, and again, this is actually, I mean, I would call it a trivial MVD, but anyway, the trivial ones are the first 2 that I listed above. So if A functionally determines B, then A multi-value determines B. Then the third one is, so remember we had a splitting rule for functional dependencies. So here the splitting rule does not apply. And so this is that example I did earlier. So if A multi-value determines BC, it does not imply that A multi-value determines B and A multi-value determines C. So you can't split up the right-hand side. Then we have rule number 4, which is a transitive rule. B and B multi-value determines C. That will imply, like just like functional dependencies, it will imply that A multi-value determines C. Okay, and then so we now have A, B, C, D, or you can put it as A bar, B bar, C bar, D bar. If A multi-value determines B, then C, D. And this rule is somewhat, this one and this one are pretty much, in my opinion, pretty much the same thing. So, but I wanted to just put it out there so that, because sometimes people think that if you have D also in there, it doesn't work. So I just wanted to make sure that you understand that. And if A multi-value determines CD, B, and then you have and if A multi-value determines BC and A multi-value determines CD, then A multi-value determines C. Okay, so this one is a bit, tricky. So if you have A multi-value determining BC, so if C is common in both of these, then you can just say that A multi-value determines C. And then I have two more rules. I'm going to put it out there, though I want to say that the next two rules can be derived from the above rules. So, but it's good to have them. So, if A multi-value determines B and A multi-value determines C, then A will multi-value determine BC. And then the eighth one is if you have a functional dependency of AB going to C and an MVD ABC going to D, that'll imply that AB multi-value determines D. So these were I know there's a whole bunch of these rules. Some of these are repetitions, and I wrote them down because when you do fourth normal form decomposition, it's good to have some of these rules out there. And like I mentioned, some of these rules can be derived from earlier rules. So these two, for example, it can be derived from rules 1 to 6. And the trivial MVD rule. In fact, there is another one too. I should put this next one. So this one also can be derived from the above rules. So if actually, I don't know. I think that what I want you to do is figure this out. So I'm not really, I'm not exactly sure about the next one. So the question is, if A multi-value determines C and B multi-value determines C, does A B multi-value determines C? Okay, so this is something you can just think about. You can either come up with a counter example, or if you should be able to, if it is correct, you should be able to prove it from the rules 1 to 5, because rules 1 to 6, rules 7 and 8 are really derived from the above two rules. And so this one too, if it is holds, you can derive it from the first 6 rules. And if it does not hold, you can easily come up with a counter example. Okay, so so these were just some of the rules. And like I said, it's just good to have them there when you're doing fourth normal form decomposition, because unlike FDs, these are a little harder to figure out. I mean, even to come up with an examples are not necessarily that easy. Okay, so any questions so far? So then I want to move on to the fourth normal form. So we have, so let me write down the definition of the fourth normal form. And remember, if fourth normal form is stronger than any of the other normal forms you've done, so if a relation is in fourth normal form, it's also in Boyce chord. So a relation R is in fourth normal form, if whenever A bar multi-value determines B bar, if whenever A multi-value is a non-trivial MVD, then A is a key or a super key. So essentially what fourth normal form is saying is that you should have no non-trivial MVDs in a table R. No non-trivial. So the only MVDs that you should have in there are trivial MVDs. So it's in fourth normal form if it has no non-trivial MVDs. So so for example, if you have a table R with 4 attributes A, B, C, and D, and let's say the key is A and B. Suppose the key is A, B, but we also have multi-value dependency, say B multi-value determines C, then R is not in fourth normal form. So since B, so the key is A, B, and suppose you have that. So then the point is that you have to divide this table into a fourth normal form table. Okay, so I'm going to write down the algorithm, and it's similar to the other algorithms, but I'm going to write this down and then we'll do a few examples of fourth normal form. So we have so again, just like the previous ones, the input is the table R with all the attributes and all the FDs and all the MVDs that hold on this table R. So in order to, so the algorithm in step 1, you have to find all the keys. So you find all the candidate keys for R. And then the second is a loop, just like we have in the earlier examples, you keep looping until fourth normal form. So you select a functional dependency where A goes to B, or a non-trivial MVD. So that's why it's very important to remember what a trivial MVD is. So or a non-trivial MVD, A multi-value determines B, where so where A is not key or super key. So, and remember, if a functional dependency is also a multi-value dependency, because if A functionally determines B, then A multi-value determines B. So in the next step, you divide R. So you can do R1, AB, if A multi-value determines B, or you can have R1, A, B. So remember, if it's a multi-value dependency, then A is not a key. It's A and B are both together, they are keys. So it's AB if MVD, A multi-value determines B. And then you have the next, so this is R1 could be either this or this, and you have R2, which is all the elements other than B, so R minus B. Okay, so this you just, and then you find if there's any, and then you check whether R1 and R2 are in fourth normal form. So what do I say? So because essentially you have to loop until fourth normal form. So I would say that, so the loop is already there out there. So it should be, so you just go back, it's a looping. But before, you should find the FTs and MVDs and keys for R1 and R2. So it's similar to the previous algorithms that we did. So I'm going to do a few examples unless you have any questions. Okay, so I'll start with a kind of a meaningful kind of example. So we have student. So we have a table student which has ID, name, course number, and the major. Okay, so we have 4 attributes, and we are given that ID determines name and ID multi-value determines course number. So we have a functional dependency and you have a multi-value dependency. So the first thing is the student table in fourth normal form. So in order to find that out, you have to find the key for this table. So can you check what is the key for this table student? It's really easy. So does anyone want to? So what is the key for this table student? Anyone? Is it ID and major?
What do you do about like the course number? That would be my question.
Yeah, so that's the thing. So you have to put course number also has to be the key. So that's why I just wanted you to think about. I'm glad, because at least when you thought about it, you would have wondered like, what is course number going to be? So you're right, the course. So the key is really ID. The only one that's not in the key is going to be name, because ID determines name. So you have to put in course number and the major. So all 3 are the keys. So remember, that's one of the things I was saying. When you bring a multi-value dependency down, so when you do the functional dependency, only A was the key. But if it's a multi-value dependency out here, both A and B are key. So I should actually write that down out here. So for here, the key is A, while here, the key is A, B together is the key. So that's why, even though ID multi-value determines course number, that means you can, so that's like saying that student 1, 2, 3, 4 can take 3 different courses or 4 different courses. So ID does not determine course number, it multi-value determines course number. So this is the key. So you have to start with the key. And then the next thing is that, okay, so when you look at this table student, the key is ID, course number, and major. And you have a functional dependency where the left-hand side is not a key. And you have a multi-value dependency where the left-hand side it's a non-trivial multi-value dependency. So you can start with either this one or this one, it doesn't matter. So let's start with, easier to start with the functional dependency. So I'm going to start with, though you could start with either, I just saying start with functional dependency that is violating fourth normal form, or it even violates Boyce-Codd normal form. In general, when you decompose, start with functional dependencies. It's much, I think that's easier to start with the functional dependencies that are violating. So we have R1, which is ID and name, and the key is ID. And then you have R2, so you bring ID down. So we have ID, course number, and major. And the key is all three. Okay, so now we have these two tables. So when we take a look, the first table, so first let's start with R1. So R1, all it has is a functional dependency. ID goes to name, but left-hand side ID is in fourth, is a key. So this one is in fourth normal form. So there's nothing you need to do out here. So therefore, we look at the next one, table R2. And in the table R2, we do have this functional dependency. We have the functional dependency ID, multi-value determines course number. So we have this functional dependency, and remember the rules also that I had shown earlier. So let's go to, so I'm going to have to scroll up. I don't have any other options. So yes. So if you look at rule 1, if A multi-value determines B, then A will also multi-value determine C. So therefore, so that's this rule. It's also could be this rule if you want it. It's the same. Actually, this rule and this rule are pretty much the same thing. I just wrote it down separately because sometimes it's easier to remember that part. So by that rule, we have ID multi-value determines course, which means that ID will also multi-value determine major. Okay, and this is a non-trivial multi-value dependency because ID is not a key. So this one is not in fourth normal form. So we have to divide it. So we have okay. So we have R3 and R4. And now R3 and R4, they are trivial MVDs out here. So these are, they do have an MVD, but it's a trivial MVD. Both those are keys anyway. So these are both in fourth normal form. So therefore, the table R, that is student table, is equal to R1 join R3 join R4, and R1, R3, and R4 are in fourth normal form. Okay, so and you could have also actually, like I mentioned earlier, you could have also actually started with the multi-value dependency. ID goes to course number, and then divided the tables. So any question, and you would have still arrived at the same thing. Even if you had started with this one, you would still have come up with these three tables. So sometimes you will come up with different, but in this particular example, you would have just come up with these three. Okay, so I would like you to try out this next example. If you have any questions, just jump in. So let's look at this next example. Oh, so I have put up the assignment based on functional dependencies and normal forms up till Boyce Codd normal form. So you can take a look at it. For that particular assignment, you can either do it online. I have an online version, but if you'd rather write the answers on paper, either you can fill up, I think that I put a PDF, you can either fill up the spaces out there, or if you just want to type it in, but when you type it in, please make sure that you type the answers in order, because it's a lot more difficult to grade if you write question 1 and then jump to question 10 and 9. It's much more difficult for Shihong or anyone to grade it if you are writing your answers out of order. So if you are submitting it as a PDF, either you can fill it in the spaces that are provided in the PDF file I put up, or you could type it in, but do type it in order. So the only thing is, if you are doing submission of a PDF file, can you please do it onto My Courses, because it's a lot easier. And now she doesn't need it to be submitted to Agate because she's not running anything. So it's much easier if you submit to My Courses, because she just can click on it and look through and grade it. So now, since we are into April, I'm going to try to finish off all the assignments that you have in this class by the end of April. Because May usually, most classes, you have a whole ton of projects and other things that show up. So I would, I'll try to finish off, at least for this class, all the assignments by the end of April. So right now, this is assignment number 8. Most probably, they're just going to be 10 assignments in all. The next assignment is going to be on fourth normal form and MVDs, and I will try to put it up by Wednesday this week. So because I know that some students have already completed assignment 8. So if you want to start up on assignment 9, you can do that. So I'm going to try to get it done by Wednesday. And then after that, there will be assignment on design, the ER diagrams. But it doesn't mean that I'm going to finish all the topics. There are other topics like, because I haven't done concurrency, there's concurrency and there is constraints and triggers. So there's a whole bunch of other topics, but those are topics where I will put up assignments on those two, but you don't have to do, they won't be graded. I'll just put it up for you to try them out, because those are, by the time you get down to constraints, triggers, and concurrency, you really have to go into SQL and try them out. It is extremely difficult to understand those topics doing them in theory. They have to be done by actually typing in. So even the assignment that I give are really labs where I want you to go into SQL, MySQL, and make those changes. So that's the reason I said that when I do give those assignments, they won't be graded because they're really labs, but I do want you to try them out, because if you don't try out concurrency and you don't try out constraints and triggers, you don't really understand how it works. You have to really see those things in action. So I just wanted to give you a plan so you can plan it out, So in May, I'm going to try to finish at least assignments at the end of April. I'll still keep giving quizzes because I think quizzes are a good learning experience for you. You may think you understand when you're in a lecture, but you don't really understand until you